Alright, and while we are working out of the book today, so if you have your book, turn to page 262. 262 if you've got your book.
You know, I'm gonna be honest, I forgot we even had a book in this class. I don't know where mine is. It's in my backpack, but I don't use my backpack either, so I forget where that's at too.
Alright, we're going to look at number 8 on page 262. That's the first problem we're going to look at. I'm planning on doing about 6 examples. We may only get to 5, but I'm shooting for 6. Alright, number 8 says the sum of the first number squared and the second number is 54, and the product is a maximum. And we need to stop and go all the way up to the top, where it says in exercises 3 to 8. It says in exercises 3 to 8, find 2 positive numbers that satisfy the given requirements. So I'm looking for 2 positive numbers that satisfy the given requirements. And in our case, the requirements are the sum of the first number squared and the second number is 54. And then the second one is the product is a maximum. Alright, so we're working with optimization. So let's rewind and talk about the steps to optimization. What's step 1? Find the primary equation. Alright, so there are 2 different equations in here. How can I identify which one's primary? What's the key word I'm looking for? What's the key word in there that's going to help me figure out which one's primary? Maximum. How do I, okay. So why does maximum tell me that's my primary?
Good question.
You are correct though.
That's how we find.
Yeah, whatever you want to optimize, that's your primary. Whatever you want the maximum, minimum, largest, smallest, on and on and on, that tells me that it's the primary one. Okay? Alright, so who can give me a formula for the primary? It says the product is a maximum.
Which times was there something like that?
Well, go back. What is it we're trying to find? Go all the way to the top. 2 positive numbers. So I need to identify 2 positive numbers with variables. So what variables do you want to use? What do we use all the time? X and Y. Okay? So my two positive numbers are X and Y. And I would want what to be a maximum? Product. So what does product mean to me? Multiplication. So we're going to say my product is X times Y. So there is my primary. Alright, so that's step 1. Identify your primary and write it down. What's step 2?
Your secondary.
Secondary. So what information in here did they give me that's my secondary? The sum of the first number, I'm looking at the wrong one. Sum of the first number squared and the second number is 54. So who can translate that for me? Roshan? Say it again. X squared plus Y equals 54. Perfect. Any questions on how you got X squared plus Y equals 54? No. You need to speak up if you do. Edmund, is your hand up? No. Okay. Everybody good with that? Alright, now what?
Didn't you put them together or combine?
I got to do something before I combine.
You got it. Yeah.
Yes. In my secondary, I need to solve for one of those 2 variables. Which one's going to be easier to solve for? Y. So let's solve for Y. Okay, so we wrote the primary, we wrote the secondary, we solved for a variable in the secondary. What's next? Substitute back into the primary. So P equals X times 54 minus X squared. Very good. So we got the primary, secondary, solved for a variable, substituted. What's next? Before the derivative, what do I want to do with that? Yeah, simplify it. Clean it up. So that's going to be 54x minus x cubed. Primary, secondary, solve for a variable, substitute, clean it up. Khalidi, what did you say was next? Derivative. Alright, so I get P prime equals 54 minus 3x squared. Somebody raise your hand. What's next? Raise your hand. Don't blurt it out. Lilani? Set it equal to 0. Good. primary, secondary, solve for a variable, substitute, clean it up, derivative, set it equal to 0. That's what we've done so far.
Wait, why'd you say it?
All right, good question. Alini wants to know why we're setting it equal to 0.
Oh, because
Prashant?
to get
Go ahead, Prashant.
Because we're finding a maximum.
We're finding a maximum. What does that mean?
So you have to set it equal to 0 because 0 is a critical point.
Yes. All right. And maximums, relative maximums, are going to occur at my critical points. So I'm setting my derivative equal to 0 to find my
So
critical
it would
points.
be semi if you're looking for minimum, right?
Correct. All right. So let's solve this. We get 3x squared minus or equals 54. I divide by 3. That is 1 and 8. So I get x equals. I'm going to start off with plus and minus the square root of 18. But what did the problem say I was looking for? Positive numbers. So I only care about the square root of 18. Okay? Now what?
Plug it in.
Plug that back into the secondary to figure out what my other number is. So if I plug the square root of 18 in there, that works out nice for me. Because when I square the square root of 18, I just get 18. And so I'm going to end up with 36. So my two positive numbers are 36 and the square root of 18. And tell me what's special about those numbers.
they
No, they are both positive. Raise your hand though. Somebody raise your hand. Tell me what's special about those numbers.
Square.
No? Ryan?
They're the optimal values for your primary.
All right, I want more specifics though. What did the problem say we were trying to find? All right, so translate it all. What are these two numbers?
They give you
They are two positive numbers where the square of one plus the second equals 54, and when I multiply them together, I found a maximum. So that means there are no two other positive numbers I can plug in here that give me 54 that when I multiply together are going to give me a bigger number than these two will. That's what we just found out. Okay? So we would get 36 square root of 18 when I multiply them together. Somebody that has a calculator, tell me what that is approximately.
Times the square root of 18 is 152.735.
So there are no two other numbers where this happens and they equal 54 that when I multiply them together, they will not go any higher than that right there. That's what we found. Okay? So, step 1,
identify primary.
primary. Step 2,
Identify
secondary. 3,
get one variable.
solve for a variable on the secondary. 4, substitute. 5, before the derivative, clean it up. Then we have the derivative. Then we set it equal to 0. We solve. Now notice, what did we do to one of our answers? Because we got a positive and a negative to begin with. We trashed one of them because why? It didn't fit. It didn't fit in what?
What they told you, the situation, the
Right, but what's the math word? What type of values? What type of value is this right here? There's always two types of values.
positive.
One that I put in and one that I get out.
oh, independent.
Well, another math. Domain and range. Thank you. Okay. One of these did not fit in the domain. What was my domain in this case? Positive numbers. Okay. That was my domain. So make sure they fit in your domain. Okay. If there's more than one answer, then we'll deal with that down the road. Okay. And then make sure you answer the question. We got 36 and we got the square root of 18. Next problem. All right. Next one we're doing is 16. All right, 16. We have a function. F of x equals the square root of x minus 8. We have a point 12, 0. Directions say find the point on the graph of the function that is closest to the given point. So can anybody translate that for me? What does they want me to do? Because usually in calculus, half the problem, half the work is understanding what it is they want you to do.
Find a point of that function that's closest to those points.
There we go. I'm trying to find something that's on this that is closest to this. And that's what they want me to find. Okay? All right, step 1.
Find the primary.
Find the primary. All right, what's my primary?
X squared. Is that one?
What is it we're wanting to do?
Find it.
Closest, which is it's a distance, but closest, what else does closest mean to me? No. In terms of maximum or minimum.
Is it max?
Closest is the minimum. So the minimum distance. I'm wanting to find a minimum distance. So that means what's going to be my primary? The distance formula. Good. Somebody remind me, besides those two, what the distance formula is.
Along.
That's the quadratic formula. That's the slope.
Oh, then x2 minus x1 squared.
I know. It's a square root over something. Square root of x squared. Yeah.
That's the square root of your x variables subtracted squared plus your y variables subtracted squared, or your y values. All right, anything I can plug into this distance formula right now? 12 and 0. I can plug in 12 and 0. Okay, 12 is an x value, so instead of x2, I'm just going to make this x minus 12. And over here, it's going to be y minus 0, so that means I'm just dealing with y squared. All right, so there's my primary. Raise your hand up, please. Don't just blurt it out. What's the next step? Hunter?
Secondary.
Secondary. All right, Hunter, you know what my secondary is?
No.
Is it that one?
It is that one. Because what else do we think of f of x as?
Y.
Y. So there's y right there. So that's the square root of x minus 8 squared. All right, we've done step 1. We've done step 2. 2 was already done for me. Well, no, 2 was 2 was already done for me. 3 was get it by itself, which is also already done for me. What's 4? Substitute, we already did that. All right, 5? Simplify. All right. So I'm going to multiply this thing out. So that's x squared minus 24x plus 144. And when I square that, I just get x minus 8. All I did was multiply everything out there.
Clean it up some more.
Clean it up some more. So I have x squared minus 23x plus 136.
Take derivative.
Take the derivative. Now, here's something that's going to save us a little bit of time. In order for the square root of something to be small, what must be small first? The inside must be small. So do I really care about the square root? Because if I find the smallest of the inside, then I found also the smallest of the square root of the inside. Everybody buy that? You buy what I'm selling? Okay. Why would I want to do that?
Easier.
It's easier. Why is it easier for me? What do I not have to do? Find the derivative of, I don't have to do chain rule, I don't have to find the derivative of the square root. So at this point, I'm just going to look at that piece right there and take the derivative of that. So that's going to be 2x minus 23. So 2x minus 23, and what do I want to do to that? Set it equal to 0. Okay, now what? Solve that. So that's going to be x equals 23 over 2, which is 11.5. Now, what do the directions say? It says find the point. Have I found a point yet? I need a y value. So, and we always plug it into which formula? Secondary. So I plug that in there. So what's that going to be? The square root of 3.5. Somebody punch that in for me. Should be close to 2. Just shy of 2. Give me 3 decimals. 1.871. How did I know that was close to 2? Yeah, 4. Square root of 4 is going to be 2. So my point is 11.5 and 1.871. All right, raise your hand. What's going on with that point? Because we need to make sure what it is we understand we're finding. Carter?
It's the point on the secondary function that's closest to 12.
That's closest to 12.0. Okay? You guys remember what the square root of x minus 8 looks like? You guys should have an idea of what that looks like without graphing it. The square root of x minus 8, what does that look like?
Like to the left.
Yeah, it's that half a parabola. Okay, and since I have x minus 8 in there, that means it's been translated. Which direction and how much?
Right.
To the right, how much? 8. So instead of starting at 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to look like that. And then 9, 10, 11, 12. So there's the point 12, 0. And then I have this point right here, 11 and a half, which is going to be about right there. Okay? Does it look like this point right here could be the closest point on this function that's on that graph? Does that make sense? That's what we found. Yes?
So like, if you were to draw a line from 12 to 0 to any other place on the function of the graph, that's the closest point to it.
Correct. Okay, so if I draw this line, and then I draw this line over here, this one's always going to be smaller than any other line I draw. That's correct. That's what we found. Okay? Everybody good with that one? All right, next one. The next one is an example on page 259. We're looking at example 3 on 259. So once you visualize it, don't look at how they did it. I want you to be able to do it on your own. Okay, don't look at how they did it. Ignore how they did it. Just look at the prompt. All right, it says a rectangular page contains 24 square inches of print. What does it mean of print? Right. If where it's got words and stuff, that space makes up 24 inches. Okay? So 24 inches is not all of the paper. Okay? Because if you keep reading, it says the margins at the top and the bottom of the page are to be an inch and a half, inch and a half, and on the left and the right they are to be an inch. So I've got the margins where there's no print. Okay, so the 24 inches squared is only the space where there is print. So I've got space that is print, I've got space that is not print. Okay, so left and right, how much was left and right? An inch. So that's an inch, that's an inch, and then how much was top and bottom? Inch and a half. So then this space in here, they said we want to be what? 24 inches squared. Okay, so that's what they give me. What should the dimensions of the page be so that the least amount of paper is used. Okay, so we want to know what are the total dimensions of this page from there to there and there to there so that the least amount of paper is used. That's what we're trying to find. Okay? Now, if you haven't opened to that page, flip to another page so you're not tempted to look at it. I want you to be able to come up with it on your own. All right, so what's the next thing we want to do? Primary. Okay? What do we want to do? What's the problem asking us to do?
Find the least amount.
Least amount of paper. How is the amount of paper represented? Area. Okay? So we need the area of this right here. So a big area. Now this one we're going to kind of do, well, no, we can do it fine. All right, so let's make this X and let's make that Y. So my area is X times Y. Are you good with that? All right. What's next? Secondary. What did they give me that was secondary?
So you're like,
Well, anytime they give me a number like that, I know it has to be part of the secondary. So something's got to equal 24.
1.5 minus 2a or 2w, and for width, I don't know.
You're close. Abby?
Would it be x minus 2 times y minus 3?
X minus 2 times Y minus 3. I like that. All right, Abby, tell us how you came up with that.
Because your x and your y are the total on each side, and then you're trying to find what the inside is, so you're taking away the margin sizes.
Perfect.
1 and 1, 1.5 and 1.5.
Perfect. So this whole thing is X. This is 1. This is 1. I'm interested in what this is. So if I take 1 away from both ends, I get the X minus 2. This one's 1.5 and 1.5. So if I take those away, I get Y minus 3. Very good. All right. What's next? Pick a variable and solve for it. So I need to solve for one of these two. It doesn't make a difference. The difficulty level is about the same. So let's solve for X. What am I going to do to solve for X?
Multiply that out.
Say it again.
You want to multiply that out?
I don't want to multiply it out. That makes it.
Can you?
There we go. Good. And then what else do I need to do? Add the 2. So there's my X. All right, what's next? So X is 24 over Y minus 3 plus 2, and then times Y. Now what?
So you change A to 0?
We haven't taken the derivative yet. So let's distribute here. So I've got 24Y over Y minus 3 plus 2Y.
So why does that become like y squared minus 2y?
Say it again.
Why does that become y squared?
That's 24.
So you just applied the y to the top. Oh, is it all one term?
Yes. All right, what's next? I would do one more thing before I get the derivative. Common denominator is what I do. So 24 plus the 2y is going to have to go to both of these, so that's going to be 2y squared and then minus 6y, and all of that is over y minus 3.
Would it not be easier to get rid of the fraction altogether?
Get rid of the fraction altogether.
Yeah, so could you make like 24y multiply y minus 3 times that? And then 2y over y minus 3? Oh, we're trying to take the derivative.
No, we can't do that.
Oh, okay.
We can only do that if it's equal to like 0.
Oh, okay.
Alright, so move over here. Alright, so put that in order. So that's going to be 2y squared minus 6y plus 24 over y minus 3.
How do you use y on 24?
That's a good question.
Yeah.
Good catch.
No.
That's going to make things a little bit easier too. So I need to put those two together. What does that give me, 18? Alright, now what? Take the derivative. What's required? Quotient rule. So bottom, derivative of the top, so that's going to be 4y plus 18 minus the top. Derivative of the bottom is just 1 over the bottom squared. Alright, now what? Simplify and set it equal to 0. So distribute here, that's going to be 4y squared. I'm going to get 18y and negative 12y, so that's 6y. And 36, what is that? 54. So minus 54. And then minus 2y squared minus 18y. This one's a little bit heavier than the other ones. Like terms together, 2y squared minus 12y minus 54 y minus 3 squared. Yeah, I can take out a 2 on the top. Y squared minus 6y minus 27. Factor that. How's that factor? 9 and 3. Y minus 9. Y plus 3. Alright, so my possible y values are.
Would you like y minus, do you like split y minus 3, y minus 2, and y plus 3, or does that not work? It's squares.
Here? It's just y minus 3, y minus 3. So, what are my three values? 9, 3, negative 3. Any of those domain issues? Negative 3. Somebody else tell me why negative 3 is a domain issue. Yeah, I can't have a negative width or length. Okay, so that's why negative 3 goes. So that means my maximum is going to occur either when y is 3 or y is 9. So how am I going to figure that out? Say it again. All right. So let's plug in and see what we get. What? We are. What did I say?
You said that.
I didn't.
You said that, like just, you said 9 and 3 with 3 words or something.
Okay. Well, 9 and 3.
We are finding minimum.
We are finding a minimum because we want the smallest amount, so that's a minimum. Okay. So if those are my y values, what are my x values? Or where do I go to get them? Plug them in here, right? So if I plug in 9, 9 minus 3 is 6. 24 divided by 6, 4. 4 plus 2, 6. And that goes with a 9. Okay, and if I plug in 3, 3 minus 3 is 0, and so that's a nasty one. So that tells me 3 is impossible. So that means my dimensions are, I have to be a height of 9 and a width of 6. Okay. What happens when I have a paper that has a height of 9 and a width of 6?
The text is 20.
The area where the text is 24 inches squared, and I've used the least amount of paper. Okay, that's what's going on there.
How did you know
how do you know that the height and width are not? I mean, like, how do you get the values, but how do you know to make them height and width?
Well, I mean, most of the times when you're writing on a piece of paper, the height is a longer piece.
Well, and also, your Y, just, and then X,
Right.
there's the width.
Yeah.
That makes sense.
What time is it?
Wow, that took up a lot of paper.
It did. All right, we get one more in.
That probably about how much room you have on a piece of paper took up a lot of room on my piece of paper. You know what I'm saying?
All right, 20. You want to hit 20. All right, 20 on 263. 20 on page 263. Says we have a rectangular solid with a square base that has a surface area of 337.5 square centimeters. We want to find the dimensions that will result in a solid with maximum volume. All right, so talk to me. I need a primary. Abby?
Is it the volume, like, equation for the figure?
That is correct. So volume is going to be it. So what are we finding a volume of? Rectangular. What do I? And so how do I find the volume of rectangular prism? Yeah, length times width times height. But what's one thing they told me about this one? A square base. So what does that mean?
Squared.
That means two of these are the same. Okay, so let's make the length and the width the same. So let's just make it W squared times H. All right, very good. So what do I need next? Secondary. Okay, there's a big number that jumps out at me. 337.5. And what does 337.5 represent? Surface area. How do I find surface area?
Is it just like...
I need the area of each side of this thing, of this rectangular prism. Okay? So, what's the area of the bottom?
W squared.
W squared, which is also the area of the top, so that's 2W squared. So top and bottom is 2W squared. What's the side panel? WH is a side panel, and there are 4 of them.
How do you do that with WH?
Because the width comes from the bottom. So if I'm getting the side panel, I need a bottom side and I need a top side. So when I do the bottom times the vertical, that's going to give me a side.
You're looking at like you have like an L.
It's kind of like you have this...
Okay.
All right, so there's my secondary. Which one of those variables do I want to solve for? And then y. I want to solve for h. Why do I want to solve for h? Right, there's 2 w's. There's only one h, so it's easier to solve for h. So I subtract it over, and then I divide by it. Alright, we come back over here. W squared, 337.5 minus 2W squared over 4W. So something nice happens for us. What's that something nice that happens for us?
Cancel out the bottom.
I can cancel the W on the bottom, which is that. So I'm going to pull a 1/4 out, and then I'm going to distribute the W. Jennifer, what's next? Derivative, good. Jarrell, what's next?
Why do you leave the 1/4?
Because it's a coefficient. Coefficients stay when you take the derivative. No, they stay. Coefficients stay. If I have a number that's off by itself, plus that number or minus that number, then it goes away. But if it's being multiplied, then it's coefficient stays when you take the derivative. But it's getting ready to go away anyway. Because when I set that thing equal to 0, the 1/4 is going to go away. So 6w squared equals 337.5. I'm going to divide by 6 and then take the square root. Hunter, knock that out for me.
Oh,
I'm knocking out the other one.
Technically, when I'm taking the square root, what should I be doing here? Plus and minus, but the minus doesn't fit in the domain, so I don't need to worry about it. What do you got, Hunter?
I put it in wrong, so.
Well, like on the AB test, we have to show the plus and minus stuff.
7.5.
7.5. Okay. And then plug 7.5 in here for me. So 337.5 minus 2 times 7.5 squared over 4 times 7.5. Don't know what that is.
Teachers, please pardon this interruption. We, for the afternoon announcement, sorry they were late. French Club meeting will be on Friday the 18th. Again, French Club meeting this Friday the 18th.
Is it?
Students, come out to watch CA basketballers battle Heritage Hall. The girls play at 6:30.
They give me units on this one.
Oklahoma Sports and Orthopedics Institute will host a 1-minute free throw contest. Come early and get your name in the hat to be drawn for the contest. Winner receives a nice prize from OSOI. Congratulations to last night's winner, Miss Michaela Shaw. Oh my goodness, I cannot speak today. Sorry. Academic letter jacket. Students, please pay attention. We will be taking pictures for both the yearbook and the frame picture in the hallway on Wednesday, January 23rd during AM Academic Enhancement. Please bring your jacket to school with you next Wednesday and report to the library for academic enhancement. 7th hour wrestlers today report to B142. Bring any homework or class assignments to complete. From the swim team, good news. We have an extra home swim meet next Friday at Rose State. So if you meant to come during the season and just never made it, now's the time. It will be senior night too. The meet starts at 5 p.m. and is free to get in at Rose State Aquatic Center. Passes will be sold before school on Friday in front of the cafeteria for $1. And a special announcement, a retainer was found in the cafeteria, so it's special lost retainer. Please go by and see the captain and exchange the retainer. Thank you.
All right, so somebody tell me what we found. What did our figure end up being? It ended up being a cube. Okay, so a cube produced what? Didn't produce. It produced maximum volume. So a cube or a rectangular prism, if I want to maximize volume, it needs to be what? It needs to be a cube. Okay, and that's something you're going to find out when you're doing these problems. Usually when you maximize something, it needs to be a cube. If I'm going to maximize a rectangle, it needs to be a square. That's what you're going to find out. Is when you're working these problems, it's probably going to end up being a cube or a square. All right. These 5.